Picture the most complete act of destruction you can imagine. Not tearing a book, burning it. No, worse than burning it, because ash you could, in principle, read. Take the book and throw it into a black hole. Past the edge, past the point of no return, gone. No fire, no ash, no scrap of a page left anywhere in this universe. The most perfect delete key that physics has ever found. And here is the fact that has kept some of the finest minds on Earth awake for 50 years and counting. Physics says the book is still there. Not the pages, the book. The writing. Somehow, uncrushably, the information survived. Tonight, why that one stubborn fact might mean the universe is not, at bottom, made of stuff at all. It might be made of answers. The question under all the others.
50 years and the argument still isn't finished, which is usually the sign of a very good question. And I love that you opened us there with the book over the edge, because we have spent 11 nights together building toward exactly this room, and most people never once get to stand in it. Throw the book in. Feel how obvious it is that the writing is gone. And then give me one episode to talk you out of it.
You'll have your work cut out because it runs against every instinct I own. Things get destroyed. I burn the toast. The toast is gone. Where does this idea even come from? That information can't be destroyed?
It comes from the very first night of this whole course. Cast your mind all the way back to the beginning. What was the first strange fact we ever set on the table? Before the qubit, before any of the machinery.
That erasing a bit warms the room, that if my laptop truly forgets a file, genuinely wipes it, not just hides it, it has to shed a tiny, unavoidable puff of heat into the air. Erasing information costs energy. You made me promise never to forget it.
The humblest fact in the whole series. It sounded like a footnote back then, a curiosity for people who build chips. And I told you to hold on to it because it was the single thread we were going to pull, hand over hand, for 12 episodes. Well, tonight we pull it the whole way. If erasing information carries a physical price, a bill paid in heat, in energy, in the hard currency of the real world, then what, in the end, does that make information itself?
Physical. A thing with a price tag is a real thing. That was the drumbeat under everything. Information is physical.
Information is physical. Say it one more time and mean it, because tonight we are going to take that sentence more seriously than any sane person should, and discover, to our astonishment, that the universe took it seriously long before we did.
All right, so take it seriously. Where does it lead?
It leads to a question asked by one of the great physicists of the last century, the very man who gave black holes their name. He had spent a long life on the most solid things there are: stars, gravity, the fabric of space-time, the guts of matter. And near the end of it, he stood up and said something that sounded almost like a child's question. He said, "I have come to think the thing at the very bottom is not the stuff, it's the information." And he put it into 3 words that people have been arguing over ever since. It from bit.
It from bit. Unpack that slowly for me, because 3 words is either terribly deep or nearly meaningless, and I can't yet tell which. It from bit.
Then take any it, anything at all you would call real. A particle, a field, that star hanging over your head. His claim was that every single it, every last one, draws its existence from bits, from the answers to yes or no questions. That if you burrow down under the matter and under the fields beneath the matter, what you finally hit at the bottom is not a smaller pebble. It's a question and its answer. Is the electron here, yes or no? Is its spin pointing up, yes or no? And reality, he suggested, is stitched together out of those answers.
Hold on, that feels backwards. The yes or no is a fact about the electron. Surely the electron comes first and the bit is just me, standing there with a clipboard, writing down what the electron happens to be doing. You're telling me he turned that around. The bit comes first, and the electron is just what a heap of answered questions looks like from the outside.
That is exactly the turn, and you should feel how outrageous it is. We are so sure the world is made of things, and that information is the thin description we drape over the things afterward. He is proposing the reverse, that the description is the bedrock and the thing is the shadow it casts. That when you ask the universe a question, the universe doesn't look up a pre-existing answer. The answering is the reality.
And I want to say, that's just philosophy, that's word games. But you've got that patient look that means you're about to show me it isn't.
Because we already met this, you and we didn't flinch at the time. Think back to the qubit. When we measure it, what do we get out?
One bit. A single yes or no. You can point the qubit anywhere on that whole sphere of possibilities, load it up with a rich blend of amplitudes, and the instant you look, out drops one plain bit, up or down, nothing more.
Nature hands you an answer to a yes or no question. That's all measurement ever gives, a stream of bits wrung out of the world one question at a time. He simply took that at face value. If the only thing we can ever truly get from reality is answers to questions, then perhaps we should stop imagining a hidden layer of stuff underneath the answers that we can never ever reach. Perhaps the answers go all the way down.
Now, you said it from bit, but we learned something this whole season that ought to change his slogan. Nature doesn't actually run on plain, flat yes or no, does she?
You've caught the update, and it's the whole reason this episode has the title it does. The bit was the old picture, the crisp, classical coin, heads or tails. But underneath, nature's questions have richer answers than that. They have quantum answers, superposition, amplitudes that can add and cancel, entanglement between one answer and another. The true atom of the world's information isn't the bit, it's the qubit.
So the modern version of the slogan isn't it from bit at all.
It's it from qubit. Every it, every particle, every field, every star, and if we're bold enough tonight, space-time itself, drawn up out of quantum information. That's the summit we've been climbing toward since the first night. And I have to be honest with you, right here at the start, before we take another step.
Here it comes.
That it from qubit is not a proven fact. It is a hunch. A profound, beautiful, well-motivated hunch that a growing number of physicists take very seriously. But a hunch. I'm going to spend tonight showing you why it's tempting, and I'm going to be scrupulous about drawing the line between what we know and what we're only wondering. Because the wondering is the best part, and it's only worth anything if you can trust me about the line.
That's the deal we've had since night one. Don't tuck me in with a comfortable lie.
I never will. So let me show you the thing that first forced physicists to take this seriously. Not philosophy, a crisis. And it's waiting for us right where you started, inside a black hole. The currency of the universe.
Before we jump in though, walk me across the bridge. Why should information behave like something that can't be destroyed? You keep hinting it's conserved, like energy. Where does that come from?
From the deepest rule in all of physics. And it's one so quiet most people never learn its name. Underneath everything, underneath every force, every particle, the fundamental laws have a strange property. They never lose track. If you knew the exact state of the world at this instant, the laws would let you run the film forward or backward with perfect fidelity. Nothing is ever truly erased at the bottom. The present always carries a complete, unbroken record of the past.
But that can't be right. I told you, I burn the book. The record is gone.
Is it though? Burn the book, and yes, you can't read it anymore. But in principle, in the most maddening, impractical, in-principle sense, every scrap of that information is still out there. It smeared into the smoke, the heat, the exact pattern of the ash, the faint light that left the flame. Fiendishly scrambled, hopelessly beyond any real reader, but not gone. If you were a perfect demon who could track every molecule, you could, in principle, run the whole fire backward and reassemble the book, word for word.
A perfect demon who tracks every molecule. We met her too, didn't we? The one who seemed to break the rule about heat, until we realized her secret was information.
The very same demon. And she's the point. Scrambling is not the same as erasing. When you burn a book, you scramble its information into a mess no human could ever untangle. But the mess still contains it. Landauer's little puff of heat from night one is about the other thing entirely. True erasure. Actually pushing the record out of existence. And the laws hate that. It costs. So here is the currency of the universe, the thing we've been circling all season. Information can be hidden, scattered, scrambled beyond all recognition, but never, ever destroyed. The books are always, in principle, still on the shelf, even burnt, even smoke.
All right, I'm holding that tight. Information gets scrambled, never destroyed. Now take me over the edge, and let's see if a black hole can break the rule. The perfect eraser.
Then let's build the most destructive object in the universe and throw the book at it. A black hole. We spent time with these before, a place where gravity has folded so steeply that there's a surface, a horizon, past which nothing climbs back out. Not a rocket, not a shout, not a beam of light. The ultimate point of no return.
The one-way door. Whatever falls in, we never hear from again.
And here's the property that makes it the perfect eraser. A fact so stark that physicists gave it a wonderfully undignified name. They say a black hole has no hair.
No hair. Meaning what?
Meaning it is the most featureless object that can exist. Take a black hole, and you can describe it completely with just a tiny handful of numbers. How much it weighs, how fast it spins, its electric charge. That's the whole dossier. Everything else about whatever fell in is simply gone from view.
Oh, that's a problem, isn't it? Because…
Follow it. Make a black hole by throwing in the book. Now make a second black hole exactly as heavy out of a piano, or a swimming pool, or a small dead star. Same weight, same spin, no charge.
Then by your no hair rule, the two black holes are identical, utterly. There's nothing left about either of them that remembers whether it ate a book or a piano.
Nothing. From the outside, they are the same object down to the last detail. So the book's information hasn't been scrambled into smoke, where a demon could still, in principle, chase it down. It looks like it's been erased, genuinely pushed out of existence, because the object that swallowed it keeps no record of it at all. The black hole isn't a fire, it's a delete key. The one place in all of nature where the universe's most sacred rule appears to simply break.
But hang on, I can rescue this. The book isn't destroyed, it's just hidden. It's inside, behind the door. The information's fine, it's sitting in there, we just can't get at it. That's scrambling, not erasing. No?
That was everyone's comfortable answer for years. The information's just locked in the vault. And it would have held up fine if black holes lasted forever. But they don't.
They don't? A black hole ends? The glow that should not be.
This is the twist that turned a curiosity into a genuine paradox. It was worked out that a black hole is not perfectly black. It glows. Very, very faintly, it leaks a whisper of radiation out into the cold. A thin, ghostly warmth seeping off the horizon. And because it's leaking energy, it very slowly loses weight. It shrinks. Give it long enough, unimaginably long, far longer than the present age of the universe, and it shrinks away to nothing. It evaporates. And then it's simply gone.
So the vault doesn't just stay shut forever. The vault slowly boils away to nothing. And now I really do have a problem. Where's the book?
There it is. That's the paradox, and I want you to feel its teeth. The vault has evaporated, so the book had better be coming back out in that escaping glow, because there's nowhere else left for it to be. But here's the cruel part. That glow, when you examine what it's made of, is featureless. It's the dullest thing in the universe. It's just warmth, static, thermal noise, the same bland hiss no matter what fell in.
The same whether it ate a book or a piano.
Exactly the same. So the black hole slowly turns whatever you feed it into identical, meaningless static. And then even the static leaks away and the whole thing vanishes. Book in, featureless warmth out, nothing left behind. If that's the true story, then information wasn't scrambled, it was annihilated. The one thing the deepest laws swore could never happen.
And you can't just shrug and say, fine, maybe information isn't conserved after all.
You can say it, but look at what you're throwing away to say it. You're not tweaking a footnote, you're tearing out the page that everything else is written on. If information can vanish here, then that perfect record-keeping I described, the present carrying the whole past, is a lie. And it's a lie everywhere, not just in black holes, because the same underlying laws run the whole show. Pull that thread and the entire garment unravels. Physicists looked at that price and most of them said, no, absolutely not. The information must come back out somehow. We just don't understand how.
So this is a genuine fork in the road. Either your most sacred rule is wrong, or a black hole isn't the perfect eraser it appears to be. And people bet the rule.
They bet the rule. And to see how it might be rescued, we have to look at the strangest number in this whole story. Because before anyone worried about the glow, someone asked a much simpler question. How much information can a black hole hide in the first place? And the answer broke everyone's picture of space. The number written on the wall.
How much information a black hole can hold? And I'd guess the answer depends on how big it is, how much room is inside. Bigger vault, more shelves, more books.
That is the obvious guess. It's the guess your whole life has trained you to make. A library's capacity is set by its volume, how many shelves you can cram into the room. Double the room, double the books. Everything we know about storing information works that way. Your phone holds more than a postage stamp because there's more stuff inside it.
Right, capacity lives in the volume, so a black hole with twice the room inside holds twice the information.
And that is precisely wrong. When physicists worked out how much information a black hole hides, the answer didn't depend on its volume at all. It depended on its surface. On the area of the horizon, the two-dimensional boundary, the skin of the thing, not what's inside, the wall around it.
Say that again because I think I misheld it. The amount of information swallowed by a black hole is measured by its surface area, not the space inside.
The surface area. Want to double the information a black hole can hold? You don't double its volume, you double its skin. And it's not a vague proportion either, it's shockingly specific. You can imagine tiling the horizon with the tiniest meaningful patches of area there are. Squares so small they're at the very limit where space itself still makes sense, the smallest tiles nature has. Count those tiles on the surface and that is the number of bits the black hole holds. 1 bit near enough per tile. The information isn't stored in the room, it's written on the walls.
That's insane. Okay, help me feel how insane that is. Give me the everyday version.
Imagine you're told that the number of books a library can hold has nothing to do with how many floors and shelves it has, that it depends only on the surface area of the outside walls, that a library the size of a city and a library the size of a closet, if they somehow had the same wall area, would hold exactly the same number of books, no matter that one has 1,000 times the room inside. You'd say the person telling you had lost their mind. And yet, for the most extreme objects in the universe, that is how nature actually keeps count. By the wall, never by the room.
And this isn't a wild guess. This one's on the known side of your line?
This one is as solid as theory gets, without our having flown out to a black hole to check. It falls straight out of combining the physics of gravity with the physics of heat, and it's been confirmed by so many independent lines of reasoning that almost nobody doubts it. Yes, the area law is real, and it is the single most important clue we have to what reality is actually made of, because it's whispering something that sounds impossible. The hologram.
Go on. What's it whispering?
That everything inside a region of space might really be a story written on the region's boundary. That the inside, the whole three-dimensional room, with all its depth and volume, might be, in some exact sense, a projection of information living on the surface around it. There's a name for a flat surface that secretly encodes a whole solid scene. You've held one.
A hologram. That little shimmering sticker. A flat piece of film, and yet when you tilt it, there's a whole three-dimensional object floating in there, with real depth, real sides.
A flat sheet, storing a solid world. And the boldest reading of that area law, people call it the holographic principle, says the universe might be like that all the way down. That a chunk of space with everything in it, you, the room, the depth, the distance from here to the far wall, could be completely encoded on a distant two-dimensional surface, with not one bit of the story lost. The inside would be the hologram, the surface would be the film.
So the three-dimensional world I'm sitting in, the depth of it, the sheer roominess, might not be the fundamental thing. It might be a kind of image projected up from information painted on a faraway wall.
That is the idea in its full, dizzying form. And now I have to be very careful with you, because we've just stepped across my line, and I promised I'd tell you exactly when. The area law, how much information a black hole holds, that's established. But the holographic principle, this claim that all of space is a projection of its boundary, that is a principle, a conjecture, a magnificent one. We can watch it work exactly, in beautiful detail, in certain simplified toy universes that physicists build as sandboxes. But whether our actual universe, the real one, works this way, that we do not know. It's believed by many, suspected by more, and proven by no one.
So, flag firmly planted. The universe is a hologram, is a hope, not a headline.
A serious, load-bearing hope, held up by the one thing we do know. That nature counts information by the wall and not the room. But a hope. Now, though, now I can finally show you the piece that made me want to spend a whole night on this. Because if the surface holds the story of the inside, there's a question you haven't asked yet, and it's the one that changes everything. How? How does a flat wall of bits become a room with depth? Where does the distance come from? The threads that weave the room.
I hadn't thought to ask. On the hologram sticker, the depth just appears when I tilt it. But you're saying there's a real mechanism, something that turns a sheet of information into genuine space, with genuine distance in it.
And this is the frontier, the actual edge of what anyone is thinking about right now, tonight, in the present day. So everything I say from here on wears a great flashing sign that reads, "We are wondering, not knowing." Are we clear on that?
Crystal, this is the speculative summit, wonder, not fact.
Then here's the wondering, and it is the loveliest thing I know. When physicists take one of those sandbox universes and ask what stitches the boundary bits into a space with depth and distance, the answer that keeps coming back is a word we have carried with us since the third night of this course. Entanglement.
Entanglement. The spooky thread from our third night. two coins, sealed and sent apart, that always land opposite with no message passing between them.
That entanglement, the purely quantum link, correlation with no classical explanation underneath it, the thing Bell taught us reality genuinely has and can't fake. All season we've treated it as a resource, fuel for teleportation, for unbreakable codes, for the machine. Now watch what it might also be. In these sandbox worlds, when you look at how strongly two patches of the boundary are entangled with each other, you find it tells you how near the corresponding places are in the space inside. Strong entanglement, the two regions are close, tightly woven, right next to each other in the room. Weak entanglement, they're far apart, and no entanglement at all.
Means no distance or infinite distance.
It means there's no fabric between them at all. They're not part of the same connected space. Picture space-time as a cloth and entanglement as the stitches holding the threads together. Where the stitching is dense, you get smooth, whole, continuous fabric. The space we live in, where here flows into there without a seam. Now start snipping the stitches between two halves of the cloth. As the entanglement falls away, the two halves drift apart. The distance between them stretches and stretches, and if you cut the very last thread of entanglement, the cloth tears clean in two. Two separate spaces with no distance between them anymore, because distance was only ever a way of counting the stitches.
So in this picture, space isn't the stage the quantum stuff performs on. Space is made out of the quantum stuff. Distance is just entanglement, seen from far away.
That's the whisper. That the geometry of the world, nearness, distance, the very fact that space hangs together as one connected thing instead of falling into dust, might be woven out of the entanglement between the underlying bits. Pull the quantum threads tight and you get the smooth space-time of your everyday life. Loosen them and space itself would come apart at the seams. Take the entanglement away entirely and there'd be no where left at all. It from Qubit, not just the particles, but the stage they stand on.
And I have to keep reminding myself, this is the wondering, not a thing we've confirmed about the real universe.
Keep the sign flashing. This is real, serious, active work. Some of the sharpest minds alive are on it, and the mathematics inside the sandboxes is genuine and beautiful and holds together. But whether our universe is truly stitched this way? Unknown. It is a frontier, and frontiers are where you're most likely to be thrilled and most likely to be wrong. Both at once. That's what makes them frontiers. The rhyme.
Can I tell you what this reminds me of? Because there's a bell going off in the back of my head and I can't place it.
Tell me. I think I know which bell.
It's episode 8, The Rescue, where noise was killing the dream and error correction saved it. The whole trick was, you don't store your one precious qubit in one fragile place, because then any little bump destroys it. You spread it out. You smear one logical qubit across a whole web of physical ones, so that no single point holds the secret and no single failure can kill it. The information lives in the pattern across the whole web, not in any one spot.
You found it. That's the rhyme, and it stopped my breath the first time I heard it too. Because look at what this frontier picture is saying. In a holographic world, where you are, a single point in space, right here, isn't stored in a single boundary bit. It's smeared out, spread redundantly across a whole web of entangled bits on the surface. No one of them holds here by itself. Here lives in the pattern, which means you could damage a good chunk of the boundary and still recover the point in the middle, because the information was protected the same way we learn to protect a qubit, by spreading it out.
So the wild idea on the table is that spacetime itself might be a quantum error-correcting code. The exact trick our engineers sweated over in episode 8 to keep a fragile qubit alive, nature might have gotten there first and used it to build space.
That's the rhyme in one sentence, and I couldn't have said it cleaner. The very structure we invented to protect information from falling apart might be the structure that holds space together so it doesn't fall apart. The fragility problem and the fabric of reality. The same mathematics wearing two different coats. Now, flashing sign, still flashing, this is wondering. But tell me that isn't the most astonishing echo you've ever heard.
It's the kind of thing that, if it's true, you'd want to sit down for. And it loops us all the way back to the book Over the Edge, doesn't it? Did we ever rescue the book? Where the book went?
We did. Or at least, the tide has turned hard in the book's favor, and this whole picture is a big part of why. Remember the fork. Either information can be destroyed, or the black hole isn't the perfect eraser it looks like. Almost everyone now bets the second. The consensus today leans firmly toward this. The information does come back out. It's in that faint escaping glow after all, not sitting on the surface like plain print, but encoded in the subtlest correlations across the entire stream of radiation, so fiendishly scrambled that it looks like featureless static to any measurement we could ever make. Scrambled past all recognition, but in the end, not erased.
So the black hole isn't a delete key, it's the most violent scrambler in the universe. The demon's fire turned up to the maximum nature allows. The book comes out as what looks like meaningless noise, exactly the way the burnt book comes out as smoke.
The most perfect shredder there is, but a shredder, not an incinerator. And in recent years, the mathematics has started, genuinely, to show how the information sneaks back out using exactly these tools. Entanglement, the boundary, the whole holographic toolkit. It's not fully finished. There are honest arguments still raging over the details, but the direction is clear, and it vindicates the rule we've clung to since night one. Information is physical, and being physical, it is precious to the universe in the most literal way. Reality will scramble it, hide it, smear it across a horizon, and boil it off into the dark for longer than the cosmos has yet existed. But reality will not throw it away. Not even down a black hole. The book is safe.
The most destructive object in the universe, and it still keeps the receipt.
It still keeps the receipt. Because the receipt was never optional. It's woven into what things are. What the whole journey was.
I want to stand back and look at the whole staircase we've climbed, because I don't think I saw the shape of it until just now.
Then let's climb back down it together, quickly, and you tell me the shape.
We started with the smallest, dullest fact imaginable. Erase a bit, warm the room. Information has a physical price. It sounded like nothing.
The footnote.
Then you showed me the bit could be quantum, the qubit. A coin doing something no coin can while it spins. And that two of them could be entangled, tied together in a way that has no honest classical story underneath. And that you could make the wrong answers of a computation cancel like waves, and the right one ring out. Real magic, you called it, and you were right.
Interference, the heart of the machine.
And out of that we got algorithms that put every secret on the internet on a countdown clock. And then the honest cold water. No, it can't do everything. It's not magic. The speed-ups are special. And then the machine nearly died in the noise, and error correction brought it back from the dead by spreading one qubit across many. And we learned to teleport a state and build codes physics itself protects. And we cooled a chip colder than deep space inside a golden chandelier to hold it all still. And we looked hard and honestly at how far along we really are, which is early. Wonderful and early.
The whole season in one breath. And now the last step.
And now the last step is the one that turns the whole thing inside out. Because for 11 episodes, information was the tool, the thing we pushed around with the machine, and tonight you've told me it might be the material. Not what the universe contains, what the universe is made of. The bit wasn't a footnote at all, it was the foundation. We spent the whole series learning to use the bricks, and on the last night, you pulled back the curtain and showed me the bricks might be the house.
The bricks might be the house. That's it. That's the whole arc, and you built the sentence yourself. We came in thinking information was a description of reality, the thin coat we drape over the real stuff. We may be leaving with the suspicion that information is the reality and the stuff is the coat. It from Qubit.
And every honest bone in my body wants to know, is it true? And you're going to tell me you don't know.
I'm going to tell you I don't know. And that not knowing is not a failure. It's the address. It's where the living edge of physics actually is, right now, tonight, while we're talking. The established part is a marvel all by itself. Information is physical, it cannot be destroyed. The universe counts it by the wall and not the room. That much is real, and it's already strange enough to keep you up. And then, just past it, there's this frontier where people are seriously asking whether space-time is knitted out of entanglement, whether reality is a hologram, whether the trick that saves a qubit is the trick that makes a where. Nobody has the final answer, and I would not hand you a false one for anything in the world. The forward look.
You know what gets me, standing here at the end? On the very first night of this whole thing, you asked a question and left it hanging. You said, if information is physical and the deepest physics is quantum, then what on earth is quantum information? And we've spent 12 episodes answering it.
We have. And look where the answer LED. We set out to understand quantum information as a thing you could harness, and we may have stumbled onto quantum information as the thing reality is written in. The course was never really about building a faster computer. That was the doorway. The house behind the door is the oldest question there is, in new clothes. What is the world at the very bottom? And the answer this whole season has been leaning toward, cautiously, wondrously, is the world at the bottom looks a great deal like information.
And here's the part that gives me the good kind of chills. The machine, the one we spent the season building, the fragile, freezing, error-corrected quantum computer. If reality really is quantum information all the way down, then that machine isn't just a calculator. It's the first instrument we've ever built that speaks the universe's actual native language.
Now you're seeing it. That's the forward look, and it's the reason none of this is idle. A quantum computer is a device that stores, entangles, and interferes quantum information on purpose, which, if tonight's hunch is right, is the very same activity the universe is doing to make itself. So the machine may become the microscope, the one tool sharp enough to let us poke at the fabric, to simulate a little patch of entangled bits and watch in the lab whether a scrap of space flickers into being between them. We might one day not argue about whether space-time is woven from entanglement. We might weave a piece of it on a chip and look.
To build the machine was to build the instrument that could read reality's own source code.
That's the whole promise, sitting right at the far edge of the map. And I won't pretend we're there. We are gloriously, humblingly far from there. But the road runs in that direction. That's what I wanted you to carry out the door tonight, and out of this whole course.
Then land it for me, one last time.
We are latecomers, you and I. The universe ran for ages before it made anything that could look up and wonder what it was made of. And here we are, right at the tail end, asking. And the astonishing thing, the thing I still can't quite get over, is that when we finally learned to ask carefully, the answer that came whispering back wasn't stuff. It wasn't atoms or fields or little pebbles all the way down. It was information. Yes or no. This or that. Entangled, interfering, uncrushable information, the same currency we found on the very first night, hiding inside a puff of heat from an ordinary laptop, forgetting an ordinary file.
We started with a bit warming a room.
We started with a bit warming a room, and we may be ending with entanglement weaving the room itself. That's the whole distance we've come, from the smallest fact in physics to, perhaps, the largest. And the thread running through every step, unbroken, from the first night to this one, never changed. Information is physical. It was true of the puff of heat. It may be true of space-time. Same thread, same 3 words, pulled all the way through.
It from Qubit.
It from Qubit. And the most honest, most hopeful thing I can leave you with is this. We don't yet know if it's right, but we finally know how to ask, and we're building the very machine that might, one day, let the universe answer. Thank you for climbing the whole staircase with me.
The bricks might be the house. I am never going to look at a single bit the same way again. Good night.